let's actually take a step further and analyze what is probability, odds, exponential, log, and log odds. This section will help us put it all together. Now, probability, as we all know, is the ratio of an outcome and all of the outcomes that are possible. It is the number of times an event occurs divided by the total number of events. The odds, on the other hand, is the ratio of an outcome and all other outcomes that there can be. So if I were to exemplify this, dice roll of 1 means it has a probability of 1 by 6. There are 6 possible outcomes that a die can have, and one of those outcomes is 1. So the probability is the outcome divided by all other outcomes, that is 1 by 6, and the odds is outcome divided by all other outcomes, that is all other values that are possible, which is 5 more. So the odds in this case will be 1 by 5. If I say I want to find out the probability and the odds of an even dice roll, what are the even numbers in a dice roll? 2, 4, and 6, right? So there are 3 situations where I can get an even number when I roll a dice. So the probability is 3 by 6. The odds, on the other hand, is 3 by 3. That is, if I'm not getting odds, all other outcomes indicate that I'm only going to get even outcomes. So I have 3 by 3, that is odds of will be equal to 1. What about a dice roll less than 5? The probability, of course, will be 4 by 6 because I can only have 1, 2, 3, and 4, which are less than 5. And the odds, on the other hand, will be equal to 4 by 2. So if I were to calculate all other outcomes, I will only be left with the number 5 and 6, which are 2 outcomes, which specify the set of all other outcomes in this case. So 4 by 2 will be equal to 2. So you see that although we intuitively understand now what is probability and what is odds, they do have a relationship within themselves, which is specified here. Odds is actually equal to probability by 1 minus probability, whereas probability will be equal to odds by 1 plus odds. We'll soon get to know why we are learning all this. Just hold on. So in this case, let's take a quick dummy example and let's create a table of probability versus odds. So I come up with a quick data frame that has probability values scattered from 0.1 to 0.2, 0.25, some dummy values. And I come up with an odds column, which is nothing but the probability by 1 minus probability of the probability column. So if I see this, I'll kind of try to understand the relationship between these two. Next, we try to understand what is E, or exponential. It is, of course, something that you've seen in mathematics, the base rate of growth shared by all continually growing processes. So if I were to see what is e to the power 1, I'll get a value of something like this, 2.72 approx. What is a natural logarithm? It gives you the time needed to reach a certain level of growth. So time needed to grow 1 unit to 2.718 units will be the logarithm or the natural logarithm of 2.718, which is close to 1. Again, looking at these values, I can easily draw up a relationship between exponential and logarithm, and they are just the inverse of each other. So if you're going to do something with an exponential, you can actually undo it using logarithm. And that's exactly what we're doing in the next step. We are trying to take the exponential of 5 and then reverse that by taking the logarithm of the exponential of 5. And we end up with 5. So we actually did an operation and then undid it using exponentials and logarithms. And now we tie these pieces of concepts together. We have learned what are probabilities, we've learned what are odds, we've learned what is a logarithm, and now I'm interested in finding the log of odds. So if I were to come up with a new column called log of odds, it would be the logarithm or the natural logarithm of the odds themselves. And that's all the suspense that I'm going to keep. So we have learned what are probabilities, odds, logs, exponentials, and log of odds. Let's see how we can put it all together so that it makes sense in the context of logistic regression.